Hi, welcome to this Superspace Theory video, and in this video I want to go over the reason that we will never find a smallest or most fundamental particle that makes up the matter or the energy of the universe. And this is because, as Superspace Theory shows, when we move inward into the subatomic realm, the realms of the very small, within the nucleus of an atom, we are no longer getting smaller, but rather moving in this fourth, fundamentally different direction, spatial direction, of the fourth dimension, moving outside of the three dimensions of our own field of space. So in my book, as well as many of my videos, I use this graphic to begin. And it shows that if we think of our 3D space as a 2D sheet, then we can imagine an object and we can look at it as we move inside of it, we can look at it as being made of smaller and smaller component parts. And that's how we view fundamental particles, as getting smaller and smaller. But in fact, if in the flatland analogy, we, again looking at our own field of space as a two-dimensional sheet, we understand it in terms of superspace theory, the core principle that size equals distance at fundamentally smaller levels of physics, we will see that an object can be made of smaller and smaller parts, but when we reach that level of the subatomic, we're no longer getting smaller, but curving in this fourth spatial direction or dimension. And I've gone over that quite a bit in my videos, as well as my book. I did want to quickly show this other cuter image where I use a little person, and this person living in a flat two-dimensional field is pointing at an object and thinking that it goes in smaller and smaller and smaller. But if they shift their perspective, you could also look at this as a tunnel leading inward in a direction that is outside of that 2D field. So to go below, this little person would then understand that what they see as getting smaller and smaller and smaller is actually them being able to observe the phenomena in further fields of a greater superspace that lie outside of their own two-dimensional sheet. And that is what we are observing when we look at fundamentally smaller particles within the subatomic realms. So I wanted to bring up a web page here, which I'll just use a brief portion under fair use policy, but this is a fundamental particle study guide. Says that fundamental particles are the universe's smallest building blocks, and fundamental particles have no internal structure. So what we're looking for in physics is a smallest particle with no internal structure. I think it's described as no mass or charge. And we're looking for this because we think things simply get smaller and smaller and smaller. So in our current theories, we look at the smallest particle. Well, we have quarks, but then we have something like the Higgs boson. And we're just looking inward for the smallest particle, but we're actually observing more and more energetic phenomenon that are not smaller. And I've gone into how the math does not actually show these things to be smaller at these fundamentally different levels of physics. So, but because we think of it as smaller, we look for the smallest particle, and one of those is string theory, which says that it's a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional, because they're incredibly tiny, in this theory, objects called strings, and then, but it says on distance scales larger than the string scale, a string looks like an ordinary particle. Mass charge determined by vibrational state. So that's been an interesting theory, of course. And then M theory is another theory which looks at the unification of all the different versions of string theory around the idea of, rather than a string, it being a brane, the smallest particle or constituent of matter. But what we see when we utilize the ideas of superspace theory is that rather than things getting smaller, and again, I've gone over this as I just did, if we look at our universe as a two-dimensional sheet or field, and we understand that going inward at fundamentally smaller scales curves into this direction of a fourth dimension outside of our field of space, and that this direction can go infinitely, which is what the math tells us if we understand it correctly. And so when we look at smaller and smaller particles, we're actually seeing phenomena which is located at deeper and deeper fields in this fourth dimensional direction. So let me go back to a brief clip from a video, which I thought was nicely showing moving inward to smaller and smaller, which are actually deeper and deeper levels of physics. So I'll play this briefly under fair use policy, a very brief clip.
And produce the energy required for life on Earth. Finally, the weak force is also the reason that heavier matter particles quickly decay into the three lighter and more stable fermions that make up matter as we know it. There are particles associated to the weak force, and we call these the W and Z bosons. The weak force is the only one of the three forces to act on all particles. In particular,
okay, and what I wanted to get to here is when he speaks of the Higgs boson, which he will do here briefly.
it's the only force that neutrinos feel.
But I like looking at this because it seems to show levels, even though that's not how it's being understood.
Finally, it's time to meet the last piece of the jigsaw. The particle that in many ways ties the whole standard model together. This is the Higgs boson.
Okay, so what I just wanted to look at here was the hierarchy of particles, which again are being seen as either, operating on the same field, or when we get larger and smaller in the understanding of physics, either within or holding other particles within them. But when we understand these deeper fields, then looking at this picture, and especially I like this way of seeing it, we can then see that we could determine the nature of these particles by the depth of the field in which they lie in the fourth dimensional direction. So going back a little forward, now that's a bit of a contradiction. So even though this is not exact, you could line these up at different fields rather than saying some are inside of others. And in doing so, you could understand more clearly why they have the particular nature that they have. So here we have a chart from Wikipedia, which means I can use it freely as I wish. So elementary particles, fermions and bosons. So let's just say that you had and this is not going to be exact. This will have to be worked out over time by real actual physicists. But say you had some fermions and bosons, and you had, up here some other stuff. This isn't the first layer under our universe, but I'm just doing a very general, and then let's say some leptons. And this is not how the picture will end up, because some of these are actually residing on probably equal fields. But say you have leptons, and then let's see the Higgs boson. We'll put Higgs down here, and then we're going to say this is where vacuum, zero-point energy, vacuum energy, or quantum foam resides. And that under this is actually a field of what superspace theory posits is essentially infinite energy that is moving up through these fields from the most energetic to the less energetic or more entropic, which I will get into more in another video. But the essence of this, even though this is not exactly where these particles will fall, and some may actually be the same particles, I am not a physicist, and these are some of the details that I'm learning myself. But what is for certain, and will shift our understanding of physics, is that instead of seeing these as smaller and smaller and more energetic but tiny, ending in a final fundamental smallest particle inside of everything else, we can see that we are progressing in this direction, a fourth spatial direction that does not have an end. There is no end, certainly mathematically, because without renormalization or mathematical sleight of hand, it does all lead in this inward direction into infinity. So there is no end to this search, and we'll simply discover more and more energetic particles the deeper we go, until finally, I would hypothesize, we'll simply come to a point of either vacuum energy or just absolute pure energy. That's my speculation, because of course I don't know, but it does fit this model of the overall greater block universe. And so regardless of what we will finally find, we will not find a smallest particle, because we are not getting smaller. We are getting further away as we go deeper in this fourth dimensional direction. And so that is why there is no end to the search for the smallest particle, and there will never be a smallest particle. Thank you for watching.